Today we are going to learn about factoring perfect square trinomials and difference of squares. Our learning goal is to identify and factor perfect square trinomials using the shortcut method and differences of squares. So far, we've covered many ways to factor in this unit. We looked at common factoring. Remember to always try to use common factoring first to simplify your expressions. Then we use factoring by grouping. Remember, these ones usually have 4 terms. We did trinomial factoring, which always have 3 terms. And so far in trinomial factoring, we looked at simple, where the coefficient of a is 1, and complex trinomial factoring, where it does not have a coefficient of 1 in front for that a value. Now we're looking at the last set of factoring in this unit, which is called perfect square trinomials. And the last one is going to be the difference of squares. And you'll notice differences of squares always have 2 terms. So I'm going to show you what perfect square trinomials are. Okay, so perfect square trinomials can always be solved using decomposition or complex trinomial factoring. But there is a shortcut method to solve them, which is the perfect square trinomial method. I'll show you what that is. If you don't feel comfortable with it, you could just use the complex trinomial factoring. First, you must recognize that the trinomial is in fact a perfect square. Here are the rules that you must follow to do the shortcut method and to recognize that it's a perfect square. So it is always a trinomial. The first and third terms, so the a and the c, are perfect squares, meaning that they're just squared numbers. And I'll show you an example of what that means in a second. The third rule is that the second coefficient must be even. And the last rule is that the middle term is equal to the expression 2 times the root of a times c. It's a little bit complicated, but we'll go through them. Again, if you're not comfortable with doing this method, you can always just use complex trinomial factoring. So if all these don't work, then you don't have a perfect square trinomial. So it's quite a few rules, but you'll start to be able to pick up on what a perfect square trinomial is. So here's an example. Right, so I just want to show you an example of what a perfect square is. Here's the example right over here. We know that this number is a squared number, and this number is a squared number, and we know what the root of this is. This is just 2 squared, and this is just 3 squared. Now, the center should be equal to 2 times those 2 numbers. So 2 times 2 times 3, which is equal to 12 in this case. And so we know that this one is a perfect square because it follows all the rules. The middle number is even. This is square root of that, and we know the middle is going to be equal to 2 times 3. So in order to recognize perfect square trinomials easily, we should be familiar with perfect squares. Can you list all the perfect squares up to 14? Let's try together. We know 1 squared, it's given here. 1 times 1, that's 1. We know 2 squared, 2 times 2 is 4. 3 squared, that's 9. 4 squared, that's 16. 5 squared, 25. 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, 11 squared, that's 121, 12 squared, that's 144, and 13 squared, 169, and finally 14 squared, which is 186. So when we see numbers like this for A and C value, it gives us a clue to whether our trinomial is a perfect square or not. Okay, so I'm just going to walk you through the steps of solving a perfect square trinomial, or factoring a perfect square. The first thing that we need to do is recognize that our expression is a perfect square. And to do that, we just look at the A and C values first, and we see that they're actual perfect squares. So we can see here we have 49x squared, and what I like to do is just write the root of that on top. So I'm going to write 7x on top. And I'm going to write the root of 1, and 1 is a squared number, it's just 1. And so we know those are both the roots of 49x squared, and the root of 1 is just 1. So now we want to see if the middle number, the b value, is an even number, and it is in this case. And then the last thing we need to check if it follows a pattern 2 times the two roots there, the 7x and the 1. So does it equal 2 times 7x times 1? And we just multiply those through. 2 times 7, that's 14x. And then 14 times 1, that's just 14x. So it does follow that pattern. So once we recognize that it is a perfect square, we can go on and make our factor brackets. So we can skip right to this step over here. And what we do is we put 7x, and we put the 1 here, we put the 7x, and the 1 here. And then we look at this middle number. We notice that, we're looking at the middle sign here. We're looking at that positive sign. And all we do is put that positive sign in between those two terms. And what we're going to do, we can simplify that even further because it's the same bracket. We could just write it like this. And that's it. All right, so what we're going to do is try example B here. And the first thing we're going to do is recognize that the trinomial is a perfect square. So the clue is you look at the A term and the C term, and we see if those are squared numbers. And we know 9 is a squared number and 16 is a squared number. So I'm going to go ahead and write what the square root of each of these would be above them. So this would be just 3x. So if you took the square root of 9x squared, and if you took the square root of 16, you know is 4. Now, we just have to double check the center number, and if it's a even number, then it's still a candidate for a perfect square. The only thing we have to check now is that the middle is equal to 2 times these two numbers that we got here. Does this 2 times 3x times 4, does that equal does that equal 24? And we go ahead and do that. You know, this is 6x times 4, and that's 24. So it is, in fact, a perfect square. So again, we're going to use our shortcut method. We're going to write our first bracket here, and then we're going to write our 4 over here. We're going to do the same thing like this. And then the last rule is we're going to use the sign of B. So on B, we have a negative value here for negative 24, so we're going to use that over here. And then we're almost done, so we can just write that in its more compacted way, 3x minus 4 squared. Okay, so it's a little bit faster than doing decomposition, but you do have to memorize those rules and go through the rest there. Okay, so let's try C here. We can see that the A term is a squared number, 36. We know that's the square of 6, and we know 1 is a squared number. It's the square of 1. Okay, so let's start off by writing down the square root of each of those numbers. You know, 36, as I said, was 6. And x squared would be just x. And on the other side, we have 1, and the square root of 1 is 1. Now, we have to check the middle term. Is it even? Yes, it is. And the next thing we have to see is it equal to 2 times these two numbers that we have here, 2 times 6x times 1. 2 times 6x, that's 12x, times 1, that's just 12x still. And so it is a perfect square, and so we could set that up. We're going to take this value here and this value here to make our signs, a 6x here, sorry, the factor brackets. And we have a 1, and then we have a 6x, and then we have a 1. And then what we're going to do is just write the negative sign, the sign that's in B, in between there, and then we're almost done. Let's finish it off with its compact form. And there we are. Okay, so let's try these trickier ones here. And the way we're going to do it is the exact same way. We just want to see if the A and C terms are actually squared numbers, and they are. We know that 5x squared, I'm just going to write the square root of that on top, which is going to be 5x. And the square root of 121y squared is going to be 11y. And then what we're going to do after that is we're going to see if the middle equals 2 times these numbers. So 2 times 5x times 11y. And let's multiply those through. 2 times 5x is 10x times 11y. And that's going to be 110x times y. So that is correct. So now what we do is we're just going to set up our factor brackets. We have 5x and we have 11y. And we know we're going to take the sign for b in between, which is negative. And then we're going to do that over here. You could actually skip this step and go straight to the final if you want. And then I'm just showing you how it works. Minus 11y, and that's going to be squared. Okay, and let's try this last one. Again, it's done the same way. First, we have to recognize that 36x squared, 36 is a perfect square number. So we know this is just going to be 6x. This one is going to be 4y. That's the square root of 16y squared. And we just want to see if it multiplies. 2 times 6x times 4y. And we're just going to go ahead and do that. So 2 times 6x is going to be 12x times 4y. And that's going to be equal to 48xy. And that's correct. So let's write our bracket here. I'm just going to go straight to the end here. We're going to take 6x here. We're going to take 4y here. And we look for the sign on B. It's positive. So we're going to put that here. And we're just going to square it. And then we're done. So you could really finish it off in 1 or 2 steps using this method. So let's now look at the final method to factor in this unit, known as differences of squares. So let's investigate for a pattern. So all we're going to do here is just FOIL each one of these and see if there's a pattern that emerges. So let's do this. We have x times x, which is going to be x squared. That's first. Outer, x times negative 6. That's negative 6x. Inner, 6 times x. That's positive 6x. And last, 6 times negative 6, which is going to be negative 36. And now we're just going to collect like terms and simplify. So we're going to notice here we're going to have, I'm just going to write it on this side here, we're going to have x squared. The negative 6 plus 6 is going to cancel out. So that's just going to turn to 0. So we're not even going to write that, and we're going to be left with negative 36. Okay, do you see that? Let's try another one. So we have 3x here, we have 3x here. We're going to multiply those together. So 3x times 3x, well, that's going to be 3x squared. Then we have 3x times positive 5. So that's going to become plus 15x. And the next one is going to be negative 5 times 3x, the inner. So it's going to be negative 15x. And then last, we're going to multiply the negative 5 and the positive 5. We're going to get negative 25. Again, these two terms, you have a positive and negative of the same magnitude. We're going to add them together. They're going to cancel each other out. And so we're going to be left with something like this. It's going to say 9x squared minus 25. And let's try this last example here. So we have 2x times 2x. So it becomes 4x squared. 2x times negative y. That's negative 2xy. We have y times 2x. That's plus 2xy. And then we have y times negative y, which is negative y squared. And again, what we're going to see is these two center parts They're going to cancel each other out, and we're going to end up with an answer like this when we simplify: 4x squared minus y squared. So we do see a type of pattern emerging here. So let's describe that pattern. So what do you notice about the two brackets in the original question? They have the same variables. If we look at that, we have x and x. So each bracket has the same variables. It has the same coefficients. But you may also notice that they have opposite signs. And I'll just write that example down at the top here: x plus 6 and x minus 6. And what do you notice about the final polynomial? What is the pattern? So looking at the final polynomial, that's going to be, I'll write the one for this example over here, x squared minus 36. They are binomials. Which means only two terms. There's a negative in between. And if you notice, each of them is a perfect square. Say each term is a perfect square. So if you're looking at this, you can see that it's 1x squared, and we know 1 is a perfect square, and 36 is also a perfect square. So now I'll show you how to use this information to factor differences of squares. So just to summarize, you first have to be able to recognize a difference of squares. So things you're going to look for: it has two terms only. It's a binomial. Both terms are perfect squares, so they're square numbers. And the two terms are separated by a negative sign. So we have some examples of perfect squares here below. And I just wrote the steps here for you to follow. So find the roots of the perfect square terms, and then we're going to create one bracket by adding the roots and another by subtracting them. So we'll do the first one here. So we can see we have 16x squared minus 25. So the roots of this, we can find the square root of 16x squared. That's just going to be 4x. And the roots of negative 25, that's just going to be 5. And now we can make our factor brackets. So we're going to do the first one, which is 4x. We're going to say add the roots. So we're going to say 4x plus 5, and then we're going to do 4x minus 5. Okay, and we're done. So that's how you do the difference of squares. Now, we have some other examples here. So I'll go ahead and do those. The first thing you'll see here for B is that we have a 9x squared and a negative 36. And the first thing you might think of, and the first thing you should do, is try common factoring first. So we have a 9x squared and we have a negative 36. So we can divide out a 9 from both of these terms. Now you'll get the same answer if you didn't do this, but you'll require more levels of factoring. Okay, so we have x squared minus 4 inside the bracket. And as you can imagine, x squared is just, what's the square root of x squared? It's just x, or 1x. And then we have the square root of 4, which is 2. So we can see that it's a perfect square, two squared numbers. It's a binomial, and there's a subtraction in between. So we can use our method here. So we're going to have x, so So we're going to find out what the root is of this. This is just going to be x, and this is just going to be 2 for each of these. So we're going to have x plus 2, and then x minus 2. And that's it. Okay, let's take a look at this one. Uh-oh. This is a perfect square, but it's more than that. So I'll show you how this one works. So the first thing that we're going to do is take the square root of each of these perfect squares here. So we're going to square root 16x to the power of 4. And so we're going to get 4x squared. And then we're going to take the square root of 1, which is 1. And then we're going to put those into our factor brackets. So we have 4x squared minus 1 bracket 4x squared plus 1. Again, it doesn't matter the order that you do them. You just have to make one. You're adding the 2, and the other one you're subtracting the 2. And so it may look like we're done, but if you're paying attention, you'll see that this is another perfect square. So we can, in fact, factor this one again. So we see 4x squared, and so we can find the root of both of these. So we're going to get a 2x. The root is 2x, and this is just going to be 1. So we can make our new factor brackets, which is going to be 2x plus 1, 2x minus 1, and then we still have this one up here. We're going to bring that down and just put it right in here. So these ones are a little bit more challenging to do with the perfect squares. So let's just write that a little bit neater for you. Okay, and let's try some of these other ones here. And these ones work the same way. They just have multiple levels of perfect squares in them. So let's find the square root of x to the power of 8. And we do that just by dividing that 8 in half. So it's going to be x to the power of 4, and this is going to be 1. So we can start writing our factor brackets. We have x to the power of 4 plus 1, x to the power of 4 minus 1. Again, we have another perfect square, so we're going to have to do that again. Okay, so we're going to leave this one here. This is a x to the power of 4. So this one stays the same, but this one here, can be broken down to x to the power of 2. Take the square root of that one, and this is still 1. So I'm going to write my new factor bracket. So I'm actually going to erase that, and I'll write it here. So we have x to the power of 2 minus 1, x to the power of 2 plus 1. Okay, so that one just factored into these two. Now, we still have a difference of squares, so we have to do it even one more time right on this term here. So these ones will stay the same. x1, this one can break down into 2 more terms. We're going to get the square root of x squared, which is sx, and then we'll get minus 1, x plus 1, x squared plus 2. We're just going to bring that one down. Oh, sorry, plus 1 from the top there. And that's how you would actually solve this. And then you can't factor that anymore. This one here, e, again, the first thing we're going to do is try to common factor. So from both of these terms, we could actually factor out a 25. And we're going to be left with 4x to the power of 4 minus 1. And as you can see, that's a perfect square, 4x to the power of 4. Let's factor that. So leave the 25 out in front. And 4x to the power of 4, if you were going to factor that, it'll be 2x to the power of 2 for the minus 1, 2x to the power of 2 plus 1. And that would be it for this one. The 2x squared is not a perfect square because 2 is not a square, so we can't go any further than that. So we'll be done at this part right over here.